This is a lesson on colour, some very quick aim, shouldn't take us too long. By the end of this you should know that white light is made up of a spectrum of colours and some ideas of how filtering and reflecting works. Okay, first up, this might remind you of the work you've done on the electromagnetic spectrum. Here's the EM spectrum across the top, and I've just zoomed in on colour here so you can see we've gone from the violet end, or the high energy end, to the low energy end. So we've gone from violet all the way through the colours to red, and I've put on the sizes so you can see that visible light has got a range of wavelengths between about 400 nanometers, which is 10 to the minus 9, I've got that here, all the way to 700 nanometers, which is 700 times 10 to the minus 9. So there is only a difference of approximately 300 nanometers wavelength from red light up through to violet light. So we are talking about a tiny part of the electromagnetic spectrum that our eyes are sensitive to, and this is what we see as colour. Okay, so did we know about this originally? This is the prism experiment, which you might have done in the lab. If you use the prism, you can shine white light through a prism, and as it goes through the prism, it refracts, and this refraction is known as dispersion when the colours are shown. And you can see that red is red is refracted the least, and purple is refracted the most, or violet. Why is this? Well, the different colours of light have different wavelengths, and different wavelengths are refracted different amounts, and it's all to do with how the light slows down as it enters the glass block. Okay, so you can see that red light is refracted the most, and purple or violet light is refracted the least. Okay, so just a quick summary to make sure you're with us for the first bit. When white light is refracted, it is split up into the colours of the visible spectrum. This is called dispersion. Different colours have different wavelengths, so their speed changes by different amounts when in the prism. The longer the wavelength, the less it's slowed down. The violet light bends the most because it slows down the most. So, for example, red light has a wavelength of 650 nanometers. What is its frequency? We've used this equation before. We can say that using speed is frequency divided by wavelength. Speed is frequency times wavelength. We can rearrange that to frequency speed divided by wavelength. And you can see we've got 3 times 10 to the 8th, the speed of light, divided by 650 nanometers to give us a frequency of 4.6 times 10 to the 14. Then a laser pen had a label on it saying 660 terahertz. What colour is this? T is tera, which is 10 to the 12. So we'd say wavelength, the lambda, is C divided by F, speed divided by frequency. Put our numbers in, here's the tera, and we've got 454 times 10 to the minus 9. So if we just flick back a little bit, we should be able to see 454, if I go all the way back here, 454 is around the violet end of the spectrum. Okay, so words that you need to know. We need to know translucent, transparent, and opaque. So opaque means lets none of the light through. Translucent lets some of the light through, and transparent lets all of the light through. So this is to do with how much is transmitted and absorbed. So you could say that opaque would absorb the light, so none of it gets through it. Translucent absorbs some and transmits others, and transparent will allow all of it to go through. So make sure you're happy with the definitions of those 3 words. In terms of filtering, how do we filter colours? Well, if we shine white light on a colour filter, the light coming out of the filter is the same colour as the filter. So can we explain? Well, if we try and look at a little diagram, we can see that the filter absorbs all the colours of the light apart from the colour of the filter. So here's our white light made up of all the colours, and here's our blue filter, and the only light that passes through is the blue light. So a blue filter only allows blue light to go through it, so therefore you would see everything as being blue, or you'd only see the blue light passing through. Okay, and then reflecting coloured, how does reflection work? Why do surfaces look a particular colour then? Let's have a look at this diagram. So if something looks red, well, why does it look red? Well, remember, for something to look red, the red light must be reflected. So you can see that only the red light's reflected, and for something to look blue, only the blue light to be reflected. So the red surface only allows the red components of the light to be reflective, and the blue surface only allows the blue light to be reflected. So when things are a particular colour, they are that colour because the surface is only reflecting that particular colour. In terms of filters, the only colour that goes through the filter is the colour of the filter. So just make sure you know and understand how reflecting and filtering works.